pretty quick.
Okay.
I think that's pretty quick right there, wouldn't you say?
No, there now.
Okay.
Hey, hello,
Recording.
everybody. Hi, stargazers. My name's Ronnie Heron from the Santa Barbara Astronomical Unit. We're over 4 years into our Astro Club's Monday morning vlog podcast called the SBAU Astro Hour. Welcome aboard. It features my very knowledgeable fellow club members on the Zoom screen around me. This will be program number 228, everybody, for July 7th through the 13th, the year of our Lord, 2025. We do cover it all. We'll go way out there to the cosmos, from distant galaxies to right back here on Earth, and we got followers as far away as India. Maybe not the same impact, I would think, as Neil deGrasse Tyson's Star Talk blog, but hey, we keep growing. Check us out at SBAU.org, our club website, or come join us, for crying out loud, all right, at the Santa Barbara Museum of Natural History. First Friday, usually our first Friday general meetings. It's not this time. It'll be coming up this Thursday. Second Saturday, star parties. We meet outside. This week, we're going to start by talking about full moon on Thursday. It's called the Buck Moon in July. It's a name you don't play with. And Dr. Kakan will be speaking about his Mars helicopter drone speech on Thursday night. Moon will be passing below Antares in Scorpius, and there's something about a major lunar standstill to talk about this week. Outward to planet Venus in the early morning sky, just below the Pleiades. We're going to introduce you to the Demon Star, just what I need, and more fireworks, this time a galaxy, the Fireworks Galaxy, NGC 6946. I've had my fill of fireworks, I tell you, gentlemen, even at home here. We could probably use the robot instruments of a worldwide network, almost 25 years old now, called the Virtual Telescope Project. And do you remember the interstellar visitor, the object Oumuamua, the Hawaiians named? And there was a Russian named one following that. Well, we got a third one, a virtual visitor. Actually, the Virtual Project Scope just captured it. And it's probably not going to stop by and see us. It's going 152,000 miles per hour. So it's an incredible hour. Let me introduce you to everybody except our outreach guy, who Chuck is on assignment on this Monday. Our beloved president and the commander-in-chief of the Starship, Jerry Wilson, is also in control of everything else. Jerry, thank you.
Good
Pat
morning
Forgy
and
is
good
his
morning,
wife.
Joyce.
Yeah. Thursday night, he'll be bringing his godson to talk to us about Mars, landers, drones. Who else joined us? Well, let's see. Tom Whittemore, who's married to lovely
Morning.
Maureen, is
Morning.
retired from his science job at Westmont all those years with those Bunsen burners.
We didn't have Bunsen burners. It wasn't
You
a
didn't have
chemical.
Bunsen burners in your
No,
lab. What
no.
did you have in there? But
Yeah,
telescopes?
just yeah, the optics, all kinds of good stuff, electronics, you name it, physics.
And you worked with Jennifer Ito, and she sort of took over running the
Well,
observatory out there.
well, she's faculty. She's real faculty. I was kind of an assistant, person there for a while, but I hit full loads, believe me.
Well, she gave us a great speech last
Really good.
October, I think it was, or November rather. Tim Crawford, President
Whoa!
Hiya, Tim. He's the
Yeah,
man
wake
that
up.
interests. What?
I just said wake up.
Oh, Tim
Yeah.
intercepts our online questions and comments. Discovered the young man in India, where it's the middle of the night, and he's out with his telescope and listening to us, I hope. His wife is Karen, longtime member. And then Bruce Murdoch joined us, supporter and telescope enthusiast. Bruce is also president of the Theater Organ Society and is married to Bonnie. When are you guys meeting inside the Arlington again, Bruce?
There's a call the Arlington today to see if this coming Saturday, which is the second Saturday, would be if the theater is open for us.
Okay.
If it is, join you. Enter by the Solar Street side door of the theater, not the front door. It'll be locked.
Well, most
And
of
it's
us will
open to
be
the
there.
public. It's free.
Okay, well, we'll bring your present. Have a happy birthday tomorrow in between. Not going to give the number, but I'm hearing myself. Is that on yours, Bruce? Can you mute?
What's that?
Yeah, I'm getting it.
Yeah, I'm getting it.
Yeah, there's
All right, let me
feedback.
close this and start over again.
Oh, darn.
Is it gone now?
Maybe bye-bye.
No, it's still there.
Now?
No, you got a feedback, Bruce.
Well, I've only got one Zoom open, so I don't understand why I got feedback.
Listen, Mr. President, let's take a collection and buy him a brand new laptop that runs the whole show by itself. Because we got silly stuff to go through. We have forwarded silly science cartoons and a few incredible thought provokers from President Jerry. There we go. You got rid of it. Hope we didn't lose your sound. You still with us, Bruce?
I'm here.
Bruce?
Can you hear me?
Okay. Solve the problem. We keep the guy in India. And now we go to the screen for the silly science cartoons. You sent us almost a dozen, and I figure we'll get about half of those. And I prepped myself to help explain what we're looking at, and I can use your help. Here we go, ladies and gentlemen.
Now, one of you guys sent this to me, so.
My daughter said it. I forwarded it. It was my daughter.
Okay.
The Mars and the Milky Way bars. What is it? What was the Milky Way as seen from Mars? That's a good one. Thank you. The first time you've ever reused one of mine.
No, I've put them up before.
That's the first I know of anyway. I remember. Here's Bart and his dad, The Simpsons. And I guess Dad is saying, oh no, Bart's saying, this is the hottest summer of my life, Dad. And he says, well, it's the coldest summer of the rest of your life, son.
I didn't get that the first time I heard it.
You tell it to those people in Texas about global warming. Cowboys would put a lantern on their saddle at night so they could find the trail when they were far from home. And that's why it was the first satellite navigation.
It's a good one. Good one.
Like a Tom Whittemore witticism. I
Final
like that.
word.
All right.
All right, who is Dr. Richard? Well, you will talk about him someday. Richard Feynman said this, quote, first principle is that you must not fool yourself, and you are the easiest person to fool.
Yeah.
Amen there. Cosmological astrophysics. Okay.
He
He's
got
still
the
alive?
Nobel Prize for quantum chromodynamics.
Yeah.
He's the quantum entanglement guy, huh?
Yeah, he worked on that for a long time, and he in retirement from Caltech, he worked on quantum computers.
Well,
Yeah.
he's entangled with a guy that looks just like him on the other side of the planet. They keep in touch. I know. Okay, this is a good one. If you go into the northern British Isles, I love the Scottish summer. It's my favorite day of the year. That's
Friend of
true.
mine friend of mine did his PhD at the University of Wyoming, and
Right.
told me that one year everybody was very happy because summer fell on a weekend and everybody got to have a picnic.
Okay, the little talking bubbleheads. It's a guy and a girl, I think, unless that's a kitten. You got to help me. I'm stuck in a time loop. And the other guy says, how long does it last? Oh, about 6 panels. No, 4 panels. It looks like 6. And then they're talking, hey, listen, have you tried climbing outside of this comic strip? Oh, says the other one, good idea. And good luck, as there goes Chuck's cat, I think.
Yeah.
Looks like it's got cat ears on him. That's a neat one. That's cute. Okay, this one is going to have to be enlarged for me to, unless one of you gentlemen would like to sing the song.
Oh, I'm not going to sing it.
Well,
Twinkle, little star, how I wonder what you are. Giant thermonuclear reaction held by gravitational attraction. Twinkle, twinkle, little star, you look small because you're so far. As you burn through constant fusion, your twinkle's just an optical illusion that happens when your light gets near, distorted by our atmosphere. Twinkle, twinkle, little star, spreading light and heat so far. As you use up fuel, you'll grow and give off a scarlet glow. That means it'll turn into a red giant. Maybe you'll go supernova, exploding elements all over. Now I know just what you are, and I know I'm made of stars.
It's pretty neat.
Or as Carl Sagan would have said, star stuff, and there are billions of them out there.
Yeah.
Boy, we miss him, don't we?
He
Not
lives,
sure if
he lives on YouTube.
Have you guys ever watched Star Talk, the blog that he does with the black comedian?
Oh, that's Neil
Neil
deGrasse
deGrasse.
Tyson.
Yeah, actually, they both did the Cosmos series, didn't they?
They each did a version of the Cosmos series.
And I think Carl Sagan was in a vast, wide interior of a spaceship, and I believe Neil went through the universe on a pen or something long, if I
No,
recall. Here we go.
He went on a thistledown.
That's right.
Yeah.
Well, what is this? Right at 3 days after the holiday.
Yeah, in celebration of the 4th of July. This is the fireworks galaxy.
Yeah, looks just like
It
Friday
is-
night down at the beach.
It is named that because it has the most recorded supernova in it. So things are always popping off. Let's see, where is that?
Also, it appears to have 5 arms. Am I wrong on that?
Yeah, it could be if you count them. Yeah, 1, 2, 3, 4, 5.
Can they have 5 arms? Don't they have to be equal, either 2 or 4?
No, nope. There's
No.
no rules.
Oh, I misunderstood this. I misunderstood in the talking points. I thought it meant that Cygnus had the most amount of supernova, but you meant the fireworks galaxy
Yeah,
has a record amount. Okay, I
that's why it's called
misunderstood
the
that.
fireworks galaxy. It has
Is that-
had 10 supernova eruptions since 1917.
Well, old man Messier missed it, but the NGC guy gave it 6946.
Yeah, that was Carolyn, what's her name? Herschel.
Oh, okay.
Um,
5 arms. I've never seen one.
Shortly after Messier. This
What was her
is
middle name? Was Lucretia? I think it was.
this is a 9th magnitude galaxy, so it's fairly bright. If he'd have focused on it, Messier could have found this sucker. Now,
He
when
could
they
have.
say it's some certain magnitude, it's the collected light of everything you see here, all compressed into a point. That's the number that's given. But when it's spread out over something here that is typically on the order of 10 to 20 minutes of an arc, it can be rather faint.
Would it be fair to say it's a bard?
I don't see a bar in there.
Kinda
Not
looks
a
like a bar
pronounced
to-
one anyway.
Okay, well, 5 arms. I don't understand it.
Well, they're not symmetric. They're not gravitationally balanced. They're not like a teeter-totter.
Really?
The ensemble of them is gravitationally balanced.
Hmm.
All of them.
It's a nice split, nice one to look at. It is in the constellation Cygnus.
The swan.
Yep.
Okay. And it just as explosive, I guess, if you want to call it fireworks, as
It's
any
just
other galaxy.
Yeah, it's a beautiful galaxy.
Now, you mentioned that it would be better with a 11-inch or larger. And so this is a faint fuzzy.
This is a faint fuzzy, definitely. Like I said, 9th magnitude is the total light, but it's spread over a big area, which makes it a challenge.
Yeah.
You probably won't see it in anything. You won't see any structure in anything less than a 11 or 12-inch telescope.
So we wouldn't be able to see this on a Saturday night star party.
Not as
Well,
a spiral structure. You could tell there's a faint fuzzy there.
Got it.
If the sky were really clear.
Well, nearby here in Cygnus is the Crescent Nebula. So, compared with the Crescent Nebula, this is probably really faint.
Yeah.
And how far away is it?
What is this? Let's see.
1,200,000 miles, isn't it? Or
Oh,
light years?
no, I didn't record the distance.
Oh, okay.
Yeah, I think if you said 30 million light years, you'd be pretty close.
Yeah, I would go along
Something
with
like that.
it.
So it's not part of the local group.
Now this is our morning sky. No, not the morning sky. This is the eastern sky in about 9 p.m. tonight.
Oh,
And it shows Antares in Scorpius
Mhm.
right there. This is the crab, Scorpius. There's the two claws. Claws used to go way up here,
Mhm.
but they chopped it off with this border control thing. So anyway, here's the claws, and then the long body and the tail comes up here. And this is Antares, a bright red star, which, as Chuck would point out to you, is the opponent of Mars. That is, it's the anti-Ares, and Ares is the Roman name for God, for Mars.
Mhm.
So, and this is the moon tonight over here. It's about 2 days before full. So it's going to put a lot of light around here. And this area is normally full of the Milky Way and all this faint structure. The star clusters you can still see, but the moon is going to blank out most of that.
The fireworks galaxy 22.5.
Oh, so a pretty good guess, Tim.
Yeah.
Yep, you were
Excellent.
right in there.
But it doesn't blow out the Milky Way ever, does it? You can still see the.
No, Milky Way from us here in Santa Barbara, it'll pretty well be blown away.
Mhm.
We'll
Oh,
not
it
see-
will.
Yeah,
Oh.
but the moon up here this bright, you won't see the Milky Way well.
Those two stars to either side of Antares there, I asked Chuck one time, they have the same name.
Here and here,
Yeah, here and that those two, they have the same name.
what
And
is
I
that?
I asked Chuck one time, I said, why the same name? And he said, well, translated, they actually mean artery.
Hmm.
So it's kind of neat that the artery goes through Antares, which is the heart of the scorpion.
Yeah.
Uh-huh.
Wow. Wait a minute. Are you saying Antares means artery?
No, they call it as well as the rival of Mars. It's also known as the heart of the scorpion.
Right.
But what are the two things with the same name, and what is that name?
The star above Antares and below Antares.
Right there and
Jerry's
right
pointing
there.
to them right now.
What's the name you're
I
talking
don't
about?
remember. It's an odd name, but translated they mean artery.
Okay.
A lot of stars start with A, don't they, because of the Muslims?
That means the in their language.
Okay.
Oh,
So anyway, Antares is a gigantic red star. It's near the end of its life. It's more massive than the sun. It's also bigger than the sun by a lot. And as it at the stage of life it's at, it has stellar winds that are spewing out heavy elements like carbon and nitrogen into space and providing many of the building blocks of life
whoa.
for the next generation.
Jerry, did you get that image I sent of the comparison of star sizes?
No.
Oh shoot, it's too bad. I sent you. It's kind of blurred out, so don't worry about it.
Okay.
But they had Antares and Arcturus and the Sun and Betelgeuse.
Betelgeuse. They're so big they would, if they were here in our solar system, we'd be in the middle of them, wouldn't we?
Oh yeah,
Mhm.
oh yeah.
God, I can't
I have
imagine.
a panel of 4 of those on my tablet computer that I show at star parties because the size range is just it's what 1,001 or more, and you can't if you try to put it all on one, you can't even see the Earth. It's just one pixel, and
Yeah, yeah.
so
It's pretty amazing.
So Tim, I've got an update for you. So those two stars that have the
Yes.
same name, all Niat.
Oh.
Niyat, the artery, all Niat.
Alfniat.
All.
Spell it again,
the.
Tom, please.
What's that?
Spell it again, please.
Niyat. Niat.
Oh, that sounds like a car.
Well, it was in my book, my old book, which I grew up with by Olcott and Mayall, Field Book of the Skies.
Yeah,
Okay.
One of the best books you could ever have growing up.
Isn't that
Oh,
amazing, Tom? Did they translate to artery? I thought that was.
I didn't know that. That's really cool, Tim.
Yeah.
Wow. I was thinking about buying a Tesla Niat next year.
There's shots for that.
I can imagine. When did you lose control, Mr. President? about 2 minutes ago.
Yeah. Speaking of Teslas, Jerry's Tesla bit me yesterday.
Oh, it did.
His door handle pinched my thumb. I was going, holy crap,
Why
Musk's revenge.
why don't you buy one of the angular trucks?
Oh,
No
wow.
chance, no chance. We just got our Tesla. We just got it new shoes the other day.
Oh,
Reached the 40,000 mile limit of the tires they're starting to wear.
Did
We
you have
got
to
that
replace the Tesla coil, Jerry?
Tesla coil, a new form of propulsion. Anyway,
shoes.
this is Antares with two looks at Antares. One is these are from radio telescopes. The Atacama Large Millimeter Submillimeter Array, ALMA, and that one, and the Very Large Array from the National Science Foundation over here. And this shows the Antares in its atmosphere, inner atmosphere. And this shows it in the VLA. And this is a big burst of gas that was of solar wind that was blown off. Let's see.
Wow.
You got a huge gust of solar wind visible on the right that had been launched from Antares and was lit up by the star's smaller, hotter companion, Ares B, Antares B. Antares is a double star.
Oh, it's a binary.
Yeah. It turns out, Jerry, that Alniad is also a double. I just looked it up.
Oh,
And I just saw a YouTube video saying Betelgeuse was a binary.
yeah.
Mhm.
Really? It's got
All
a little
the best stars, binary.
I thought over the half of the stars in the night sky are binary.
and the little one next to it is usually the white dwarf that's sucking everything off the big guy, isn't it?
It can happen. It
Huh.
depends completely. The star's fate and lifespan and lifestyle is completely determined by the initial mass.
Wow.
And so a big star growing next to a small star, the big one is going to have a hotter, faster life, and the little one is going to have a slower life with a less dramatic end.
Question remains, where would the exoplanets be in a system like that?
They would be in deep trouble.
Yeah.
That's a good answer.
Okay. Now, this
Okay.
is a composition. This is not a photograph. This is data put together from ALMA there, which can see this portion of what's going on in the star, and the VLA, which covers these different wavelengths, cover the cooler stuff out here and the warmer stuff in here, and visible gets the hotter stuff in here.
Oh,
So
I
go ahead.
didn't understand this when I first saw it.
Okay, well, this is the structure of Antares' atmosphere, or depending on the definition of where the surface is, the structure of the outer portion of the star.
Oh,
Down here, this scale here shows the position of our sun. This is Earth's position, Mars' position,
Wow.
wow.
Jupiter's
Jupiter.
position, which is here, and then Saturn's position here, and Uranus out here. So this is a big star. Now, when they're big like this, they're really fluffy. I mean, you could take a spacecraft and fly through this thing in principle and make it. You know,
I like how you said in principle.
in principle, yeah.
Be a little hot.
I wouldn't want to be that test pilot.
No,
Yeah. Radiation are us, boys and girls. But Mr. President, you said earlier, I think it was this star Antares is throwing out higher elements like carbon and oxygen.
yeah.
Okay,
And
does
Those
our
are all
sun?
below. Those are all below iron. So
I
they're made
understand
in.
that.
Pardon?
So does our sun do the same thing?
Yeah.
Our sun has a solar wind too, but
Okay.
it's throwing out mostly protons. Solar
Okay,
wind does not contain heavy elements in any abundance.
Okay, so it doesn't do the same thing. Only the big guys that are ready to die.
Yeah.
Well, it's when they go supernova and they go off with I forgot what the temperature is, but like 30,000 degrees Celsius. That's when all of the higher elements that they could form get formed, and as I don't know, 100 microseconds or milliseconds, very, very quickly.
Yeah. Yes, and it cools off enough in the cloud for molecules to form in supernovas, such as water.
Really?
Yeah.
Water gets
Okay, this is our moon tonight. It is 93% full. It's going to be full, I think, on Thursday night. So there's a lot of stuff to look at. The best stuff is going to be right here around the terminator, the day-night boundary.
and
So
it's going to be called one of my old favorite Western stars, Buck Moon.
yeah,
Yeah.
apparently this is the season when male deer get real impressive, and it annoys
You
everybody, and so they call it a buck moon.
Yeah. Yeah. His cousin's Buck Rogers.
Right, that's right.
You happen to know what time of day it's going to get full?
Let's see.
Not going to be during Martin Kakin's speech, is it? That would be awesome. Something right out of a Kubrick film.
I think it is the 10th, but I don't know what time.
You said Thursday.
Yeah, Thursday. Yeah,
Okay.
yes.
But it stays full for a day or two, doesn't it?
That stays full for a second because it's a thing in motion. But it looks full for a couple days. Just you have to really look at it to see that it's not actually full from edge to edge. You can see a slight shading on one side or the other, and it changes over about a day before to a day after full.
And we're going to have to contend with it 2 nights later on our star party.
Yep. Well, no, later it will rise later in the evening. So, and also as you're about to see, I think it's about the next thing. Oops. Yeah, here we go. I should have had this next. There.
Uh-huh.
The moon, this is a picture of the full moon. It's a picture taken every 10 minutes. 10 minutes, I believe, in 2017 of the summer full moon on July 9th and 10th. And so you can say, I don't know which way it goes, left to right, whether the thing's been flipped or not. But the point is, it's very low in the sky. The summer full moon, the summer sun is high in the sky, and the summer full moon, which is opposite the sun in the sky, is a very low arc, like the winter sun is. So the light will not particularly bother us as much as the full moon in the wintertime does, but it will be bright. So, and it will rise about an hour after on our star party on Saturday. It will rise about an hour or two after things get dark. So you will have some good viewing if the sky is clear.
You suppose, Mr. President, it transits about a degree every 5 minutes, just based on what you just said and looking at them lined up in a row there. Degree every 2 minutes, maybe, or no, every 10. Well, that's two moons make a degree in the sky, don't they?
Yes.
2 full moons thickness.
Roughly, yes. So this is 1, 2, 3, 4, about 5 full moons across there. About 2.5 degrees every 2 minutes.
Got it.
Every minute, 10 minutes, I mean.
Every 10 minutes.
Yeah, because this guy took a picture every 10 minutes.
Could we do this? Can you guys come up with a picture like this?
Got a camera, set it on a tripod, and don't touch it.
Oh, that's true. This is not through a lens, is it? Okay.
No, it is through a lens. Has to be.
Well, a camera, not through a telescope lens.
No.
Wow.
It's kind of neat. You can make out some of the constellations above there towards the top. There's Delphinus. There's Delphinus the dolphin right there. Yeah.
The earthly view.
Boy,
Yeah.
good observation.
Yeah, see that, Tim?
Yeah. Now, Jerry, in the talking points, I think it was the talking points, you talked about that height of the moon, that there's a time when it's kind of it's still.
Yeah, it's called the major lunar standstill.
Yeah, that I never heard of.
I never did either. That's what I was depending on Chuck to explain today.
Yeah. We should call him.
No, don't bother him.
Oh, no.
No, absolutely not.
It appears to stand still. Is that what
Well,
basically?
it says we're currently in the midst of a phenomenon called the major lunar standstill, which occurs because of the inclination and orbit of the moon's orbit around the sun, around the Earth.
Mhm.
During this time, the moon rises and sets at its greatest northern and southern positions in our sky. And furthermore, these positions don't appear to significantly change from month to month for a time, hence the term standstill.
Yep, never heard of it.
No, I think it's a minor effect. And you would have to note the position of the rising and setting because they don't change very much from day to day.
But is it my understanding, am I correct, that in summertime, when the sun is high, the moon goes low, doesn't it? And just the opposite in winter.
Full moon. Yeah, full moon does.
Full moon, yeah.
Just okay.
Because the full moon's opposite the sun.
Right.
Well, there's going to be people that would ask, why isn't it higher in the summer like the sun?
Hmm.
It's just it's because of the turning of the earth, isn't it? Because we're at an
Yeah.
angle that faces upward toward the sun. And
It's the tilt of the sun, tilt of the earth.
Mhm.
that's what I meant.
You reminded me of one of my favorite nonsense questions. I forget the name of the book. It was something
Dr.
like The Hitchhiker's Guide to the Galaxy.
Oh, that one.
But
Okay.
someone wanted to devote their life to studying the great questions of astronomy. For example, why does the sun only come out during the day? Why doesn't it come out at night when it would be more useful?
Yeah, you're right. Yeah, my daughter sent me another one of those pancake shots of the earthers, the flat earthers believe, an eclipse would look like. And I said, we've already done it. I'm not going to send it to the guys.
Mhm.
Fascinating.
Okay, now. Okay, we're back on track here.
Mhm.
This is a short little blurb about a star cluster in Andromeda. You can see Andromeda's border here. Looks like gerrymandering to me. So down here, there is this Messier, not Messier, NGC 7686. So this is its catalog number. The Sky 6 tends to call it Herschel H69-8. So there's a zillion different catalogs. And it's not, zillion is not an exact number, but the same things are listed in many catalogs. So you come up with all these different names. This is a very faint, underpopulated star cluster that it turns out is not actually a star cluster.
Oh,
So this is the star cluster. It's this small group of stars. I believe it's about, let's see if it says the moderate-sized open cluster containing 80 stars. Yes. At magnitude 5.6, it's an easy target for binoculars and small telescopes.
Mhm.
So what you do is to decide if an asterism, because this is an asterism, this is like a double star, but is not a binary star. This is a star cluster that only appears to be a star cluster. And what you do is you measure the motion, both line of sight motion and distance to each of these stars. And in this case, they do not have the same motion. They are just passing through each other or by each other. They are not at the same distance. Some are very much in foreground, some are very much in the background. And a Hertzsprung-Russell diagram shows that these are not the same compositions and they are not the same age. So it fails on 4 out of 4 star cluster tests. But still it's marked as a star cluster in the NGC catalog. So it is an asterism.
Wow. Would the definition of a star cluster be they got to be orbiting each other?
Not orbiting each other. They've got to have a similar motion to each other. They've got to be moving in a group down the street. Say 5 or 6 girlfriends are walking down the street in a shopping district, and they're just walking down the street chattering away. They're not orbiting each other. They're just traveling in the same direction.
And then, so the one is the similar proper motion, and then the other one is similar distance?
Similar proper, yeah, roughly the same distance. They have to be in proximity to each other. They are generally the same composition. And they have, let's see, they have similar motion, similar composition, similar ages, and similar distances.
Huh.
That I didn't know either.
Yeah.
Thank you for that. That's
Well, now
I'm trying to gather more information on star clusters for those evenings with not so good a viewing.
Perfect fuzzies, yeah.
Yeah, and so the clusters become important to the foreground. I can't always drag Tom Whittemore with me. Too bad. He's good at that.
Yeah, I like clusters. Yeah, thanks, Tim.
Well, general question, which has probably been asked before, but it's my stupid question of the hour, gentlemen. It's the Milky Way is estimated to have about 400 billion stars. How many do we see? What percentage of that 400 billion is more than half beyond the gas across the sky, or more than half we can't see? We only see a portion of those 400 billion.
With your naked eye, it's estimated that 6,000 stars over the whole sky are visible to you.
Okay, but with big powerful lenses, we can see all of them that are visible to us, but some are on the
Yes,
other
you can
side.
see all of them that are visible to us, all 6,000. But the most populous kind of star is red dwarfs, and we only see the ones that are very, very close to us
Oh,
because they're
And
really
then
small and faint. And then
And
there's
then-
a lot of dead stars that were white dwarfs that I guess are cooled off. Well, that would take a long time, so probably not.
what about brown dwarfs? I know we don't see those, but are they sort of like occupying the same spaces in the sky as a star would?
Those
They're a star-
those are in the category, in my mind, of planets that don't have a sun.
Rogue planets, or
God only knows how many of those there are. But we
And a
have
lot
found
of-
brown dwarfs. Jupiter is almost a brown dwarf. It is something that has failed its star status because it has not achieved sustained fusion. It's just heated up by its compression of all the matter that it collected, crushing together and heating it up. Jupiter is like that. Jupiter radiates more heat from its own compression than it receives from the sun.
But like Jupiter and the other gas giants, if they ever get to be that big, a brown dwarf is all gas. There's no rocks out there. There's no rocky type that big, are there?
That's like Jupiter is like that. Jupiter is believed to be a gas star with no surface. You just go through, on the outside, it's gas. On the farther in, it's deeper and warmer gas. Farther in, it's probably liquid-like and hot. And then it gets hotter and turns into a solid, but there is no surface. There's nothing to stand on. It's just a continuous, like the triple point of water. You can get all 3 phases at once.
But
So
we'll never find a planet as big as Jupiter that's all rock, no gas, except for maybe a light atmosphere.
I don't believe that that's possible. But
Ah,
since we haven't found anything like that, you can't say that you'll never find anything like that.
Would be a hell of a rock.
Yeah, I think it would crush itself into some exotic state.
Okay. Thank you, gentlemen.
Yeah.
Always wondered about that.
Okay, now this is the dawn sky,
Mhm.
or
And
pre-dawn sky, depending on how you want to look at it, because the
Yeah,
sun is not coming up.
so Jerry, I saw Venus come up at 4 this morning.
Okay,
Um,
well, this is tomorrow morning at 5.
mhm,
So, and Venus is here
mhm.
near
Yep.
Aldebaran in Taurus. This is the bull
Mhm.
snorting up and his horns going down. M1 here, a famous small nebula.
Yeah.
And then it's right below the Pleiades.
Mhm.
So this is the eastern horizon, and they've just risen at 5 o'clock or 4 o'clock.
Yeah.
Wow.
Yeah, you would have 4 o'clock an hour, you'd have seen it. It's way down here. Of course, you're up on the hill. So
Yeah, we're on a hill and we have a pretty good northeastern horizon.
yeah, well,
So
that's what
I
you
saw it at exactly 4:04 easily.
okay.
You're not looking through trees, Tom?
No, through bedroom window.
Oh.
It's through bedroom windows on his neighbor's house.
Very bright, extremely bright.
Yeah.
No,
It dominates
Jerry,
that sky.
where's Cassiopeia in this image here?
It's not.
Oh,
Yeah, Perseus is there, Tim. See
yeah, I
that?
see Perseus. That's why I was wondering about where the double cluster would
Yeah, it
be.
looks like Auriga's coming up with Capella.
Yeah.
And a fascinating thing, Tim, this summer I'm growing an heirloom tomato called the Auriga, and they're wonderful.
Huh.
Yeah, beautiful, beautiful tomatoes.
So as you can tell from the borders between the constellations, the North Pole is up here in the upper left, right up there. And the Cassiopeia would be around that one. And I believe it's on the other side of Polaris from this.
Yeah.
Well, I don't know. We maybe see it on another chart.
You have one of those tomato plants, Tom?
And I've got five plants growing right now.
So it's not a cappella?
That's right. That was pretty good.
Okay.
This is Chuck McPartland's favorite kind of sky map.
Yes.
Why, how do they make these? Sometimes they do it negative, don't they? It's black dots on a white background.
Well, this is a type of graphical representation that doesn't really show where you are in the sky, and it doesn't identify a lot of the stars. But I use this not just to irritate Chuck, but because in the constellation, this map shows all the Greek letters for the stars, roughly in order, with Alpha being the brightest, and it shows the magnitude of them. And while you get better location maps with the planetarium softwares I use, it doesn't show these features. I can't make them stand out, the Greek letters. And yet the text refers to those things. So I like to put this up every now and then. This is the beta star in Perseus. You know, they're labeled roughly in order in the Greek alphabet: alpha, beta, gamma, where somewhere gamma, and delta, and they're roughly in order. Not everyone is like that. Somewhat the beta is brighter than alpha, but I think that's only a 1. Anyway, this is Algol, the brightest star in Perseus, and it's a demon star. It is actually a triple star, but it's been known to be a double star at least for a long time, and it's an eclipsing. It's an eclipsing binary. So
Eclipsing.
just under every 3 days, 2.867 days, it dims. Let's see if
One transits the other.
Yes.
Yeah. So this is, first of all, this is where the brighter one is eclipsed. So the magnitude drops from 3.4 to nearly 4. And then this is where the dimmer one is eclipsed by the brighter one. So they rotate around each other in a plane very close to our line of sight. So you get the full effect of the two eclipsing each other as they go around and around.
That's why that happens.
Well, is that part and parcel to why it's called a demon?
You could, in olden days, as a lot of these things that were visible to the naked eye got names, interesting names, and fabrications or myths about what they looked like or what they represented.
Right.
And this was one that you could look at, and while you look at it, you can see one of these eclipses happen, especially the big eclipse, and it looked like the star was winking at you.
Right.
And so it was referred to as a demon.
Right. We get the word ghoul from that, Ron.
Do we really?
Yeah, the word ghoul. Mhm.
Did it have to do with something to do with like an evil eye?
Yeah.
Exactly.
Mhm.
Oh, but most binaries that do eclipse, they're not on edge. We're not seeing them edge on, are we?
If you see them eclipse, they are. And
Yeah, that's what I mean. But what are the odds?
That's interesting question. And let me skip it for now. No, I'm just that's how we see that's one of the key methods of finding planets, around stars, is
Yeah.
the line of the ecliptic on that world happens to line up with our line of sight. But about around 10% of objects, if they orbit each other, they're going to be, it depends on their sizes, but it's around 10% or less of objects that eclipse each other line up with our line of sight.
Well,
Yeah,
if one if one of them,
interesting story, Ron. An interesting story about this star was the fellow who actually posited that it was an eclipsing binary was a guy named Goodrick. And he actually died of pneumonia. He was brilliant. He was a deaf mute, and he would watch the stars. Okay. And he noticed this. And I think he may have been the one to suggest it was eclipsing binary. Okay. John Goodrick. He didn't live very long. I think he maybe made it into his early 20s, but he would be out watching this stuff all the time, England, and he caught pneumonia and he died.
wow.
Yeah.
Well, how would you be able to tell the difference between an exoplanet, which is not bright and lit up like a star, which would dim the star we're looking at as it goes in front of it, and another companion that's also a star? Why would it dim at all? There'd be one bright thing going over another bright thing. Why would it dim?
The dim thing blocked out an equal portion of the bright thing. So there's a slight
Right.
dip.
Right. And when you add them together on, you
Yeah.
get dim sum.
My favorite. Welcome to the Chinese restaurant, Astro Hour. I love it.
Tom, you're a card and need to be dealt with.
Yeah, right.
But we normally can't see those companions, right? And we just know they're there and lit up, but they're so
Right.
small. They're what, a red dwarf, and it goes in front of its companion and dims it a little.
No, we can see the spectra of it and the radiant and the
Right.
color of it. So we know it's not a red dwarf.
Mhm.
And we know
Oh.
it's an exoplanet.
No, I was talking about binaries that eclipse, like this
Yeah.
this one you're showing us.
They can be anything, including
Well, I mean, when they can see one planet, can they see all of them do it? Our planets don't always transit the sun, and at least the ones in
it
from us.
depends where you're looking from.
That's true too. You're right.
If you're looking from far away and you're on our ecliptic, you're going to see a lot of little eclipses if you have the right instrumentations. This is an image made by an interferometer called the Chara interferometer. It has 1/2 milliarc second resolution.
Wow.
That's just very tight. And it shows Algo A and Algo B and Algo C, the third star in the companion. This one
Wow.
does not eclipse these two stars.
But it goes around both of them?
It goes around both of them, and they go around it.
Wow. People on exoplanets out there have a nasty time, I would think.
Now, the claim with the interferometer is that the slightly non-circular shape of algo A and algo B, but not algo A, is a real effect. The star is really that shape.
Really?
But algo C, it's an artifact of the instrument that gave it an elongated shape. So this star, algo B, is apparently distorted by algo A and vice versa slightly. But these go around each other every 3 days. So they're really close. It's, we find these giant exoplanets that are hot Jupiters that are going around each other with periods of a few days. This is two stars that are doing that, so they are going to be distorted.
Isn't Alpha Centauri with Proxima similar to this? Isn't it a 3-star system? Our closest neighbor?
Yes.
It's similar to this.
It's a 3-star system. The stars do not rotate around each other with this degree of closeness.
Okay, but the planet they're talking about, Proxima, would be orbiting their algal C of the Proxima or the Alpha Centauri system, right? The little one, the outward one.
Yeah,
that's
the outward
closest
would
to
be
us?
rotating around. They have a more complex dance, but they would be the little one is farther out and orbiting the other two.
How did I remember all that? Jesus.
Bruce, are you still with us?
I think he's asleep.
He's been asleep.
I think he froze. His computer froze.
Yeah, I might have frozen. Yeah.
Yeah. Okay.
We still got to talk about the virtual project, virtual telescope, and our new visitor. Can we get that in time?
Yeah. This is just a quick look at the size comparison of the sun, bottom, middle. Algo A2 is right, and the blue giant is Bellatrix. So Algo is a bigger star than the sun, and it shows it here undistorted, but with something else orbiting it that close, I'm sure it's distorted. Now this is, let's see this, I got two of these charts. One was, we are being visited by another interloper from interstellar space, like Oumuamua. What?
This one doesn't have a cute name yet.
Oh yeah, it does.
That's not cute to me. It's a phone number, isn't it?
3I Atlas. It just rolls off the tongue.
Okay. Wasn't there a second one that came through with a Russian name?
Yeah, there was Comet 2I Borisov in 2019, Oumuamua 2017. The I in the name, see here it has, well, it doesn't N1, but in its notation N, where was I? Oh yeah, this is 3I Atlas, and the I stands for interstellar, comes from interstellar. So this is the third interstellar object. There was that one that was picked up by the military, but the data was classified and was not released. So, this is possibly the fourth. But officially in astronomy records, it's the third. And this is another picture of the same graphic showing how it comes in. This one shows its position relative to the ecliptic plane. So here's, if it was on the ecliptic plane, which it's not, but it's below the ecliptic plane, and going out, it's above the ecliptic plane.
Got it.
And it's going in, it's going to come closest to Mars, I believe, in it's magnitude 18.8 right now.
Yeah.
So none of us are going to pick it up on our backyard telescopes unless we are taking a very long exposure. Oh, that's right, October 30, the day before Halloween, is its closest approach to Mars. So all the kids out with their trick or treats on Mars, they're going to be able to see this go by.
Jerry,
according to I'm sorry, but according to your talking points, Mr. President, this was discovered by that virtual telescope project. Is it
Yes, I'll
possible
get to
to
that.
integrate?
Yeah.
You're going to get to that. I'm sorry, Tim, what were you saying?
well, I think it's an aside. I'm just curious about the ecliptic plane and this traveling below or above the ecliptic plane, and what type of an influence would that have? Is it gravitational influence? Would it be able to slingshot it in some way, a very small amount, or is it insignificant?
Nothing significant. I mean, it's moving up. This is very fast. It's moving 150,000 miles an hour. Things that are in our solar system and captive by the sun are typically moving between 30,000 miles and up to 60,000 miles an hour, depending on what they're doing and where they are and where they came from. But interstellar things, they're really zipping through here.
Boy,
So we're not going to have much effect on it. That's like saying, what is the effect of a paper target on a bullet that just went through it?
okay.
Can they tell the shape of it?
Tell the shape of it. Of the
Well,
object?
remember
No.
Oumuamua's shape.
Yes, that was because we got radar signals off of it. And
This one we don't.
it was tumbling and we could see the change in brightness as it went around. So it was the Oumuamua was either a long pencil shape or a flat pancake shape. Couldn't tell the difference between the two.
Wow. Well, there's supposed to be an endless amount of rogue planets that don't have stars to orbit that are racing around. If we ever got one of those, we'd be in trouble, wouldn't we?
No, it just zip on through too. And this could
Really?
be one of those.
Wouldn't affect our orbits at all?
Not unless it hit something or came really close.
Well, thank you. I can sleep better now that you've said
Yeah.
that, Mr. President.
Here, the arrow is pointing to the only dot in the entire frame. And that's because this telescope tracked this image, and all the other stars are streaks because
Oh,
it's
wow.
tracking the 3I atlas.
Huh. I don't think it's washed out, but it looks like a streak to me that it's pointing.
It's washed out. Okay.
Maybe it is. I don't. So it's going to be in the solar system at that speed for how long, you think? Does anybody know? Any ideas?
No.
The planets aren't going that fast, are they?
No, nowhere near. Can you see this now?
Yeah.
Oh, yeah.
Okay, there's the dot
I
right
see
there.
it.
And this arrow is pointing right to it. So that is the object, and it was tracked. Now the fact that in what is this, an hour-long exposure or something? Oh, it's taken with the C14 plus, unfiltered, 14, average of 14,120. So 2-minute exposures, 14 2-minute subframes added together. So 14, 28, 30 minutes. This is how much that thing is moving, is this distance. And it's way out there past Mars. It's really hauling.
Wow.
You know, Jerry, I saw you and Tom track a comet up at Westmont one night.
Yeah.
I still don't understand how you can get a big telescope like that to track a comet that's used to tracking the sky.
Well, the comet's in the sky, so half your problem is solved.
Okay.
But we were not tracking it per se. Software, if you have the right camera and the right software, you can track the object. But we didn't track the object. We watched it. We knew the path and we knew where it was going to go. Tom and his student had star charts and or software that could tell where it was going to be. And then we moved the scope to the place where the comet or that object was going to be. And then we watched it pass through the frame and then ahead to where it was again.
And comets go a lot slower than this visitor of ours.
Yes, a lot. Now
Okay.
the Virtual Telescope Project is a real-time online observation set that offers public online observing sessions. It's used for all sorts of things, scientific research. It's a set of telescopes like Las Cumbres Observatory is, but Las Cumbres is spread around the globe. This is in a specific place. It communicates, it's for science communication and public outreach. You can look it up on Google. It focuses on near-Earth objects, such as asteroids. It uses advanced robotic telescopes, state-of-the-art, located in, and I can't pronounce these are in Italian,
Chicano.
in Italy.
It's in Italy.
Yeah,
Yeah,
with
Chicano.
specific capabilities for high precision photometry and let's see, philanthropic activities. Okay. So this is the site. These are the
Yeah.
telescopes.
Yeah, 14 inches, Jerry.
Yeah, 14-inch.
Is there a cost or is it first come, first serve?
It's a philanthropy project. So it's like most scientific instruments. If you have a grant that has written into it that you are allowed to purchase time, then you move right to the front of the line. If you just have a good idea, but you're church mouse poor, they will try and squeeze you in. But it depends on, there's a committee that decides on things based on importance to science, urgency, and finances, that mixes all those things and makes a judgment call on who gets time.
But none of our club members have scopes this big.
What's that?
Oh, yeah.
None of our,
I
sure.
have scopes
I
bigger
have
than
a
this.
homemade 18-inch,
Yeah,
but I don't have a Paramount. Can't afford them. That Paramount
the
mount.
is
That
the
red
18
mount.
Okay. Is that Palmer Observatory at the museum? Is that an 18-inch?
No,
20.
they had 20-inch plane wave.
Oh, well, then we don't need these, do we? We'll let the rest of the world. We got,
Wow.
hey,
Not the hell
gentlemen.
with them.
Oh, it's 12:02.
Yeah.
Yeah, we're into a little past, but there is no set time on YouTube videos. We are a weekly thing, and we could do 2 hours here if we wanted. Do you want to do one more thing, Mr. President?
I think we have one more thing.
Okay, you got it.
And that was just a bonus thing that I added. This was
Giant eyeball in space.
no, that was earlier. We did the eyeball.
Oh, okay.
Oh, we have two more things. Well, we can do these next time.
Okay.
All right, please.
Okay.
All right, let's do it again. Let's meet around our hearths and man caves and get together. This Thursday, it'll be your godson, Dr. Kakin, NASA's Ingenuity pilot for the helicopter on Mars. And we'll be back here for number 229 of the SBAU Astro Hour. How would Chuck say good night, Gracie, as in George Burns in Astro Talk for saying adios? Anybody want to take over?
Yeah,
Good night.
I'd say
Hasta
Mrs. Calabash, wherever you are.
I would say do widzenia.
That's right.